Welcome. In this video, I show you how to find temperature distribution of the solid domains. Our model has two domains. One of metal copper and another is aluminum. The boundary condition of the model are insulation. This boundary also, this boundary and this boundary are insulation. So we do not have any heat flux from these boundaries. Okay? But inside the domain we have copper that heat source is equals 1E6. Okay, so for start the simulation, let's move on to COMSOL Multiphysics. Click on Model Wizard. We have 2D models, so click on 2D. We have solid domain and we want to find heat transfer or temperature distribution, so we go to heat transfer. And also we have only solid domain, so we click on heat transfer on solids. Okay, click on Add, click on Study. In this section, we need to define the stationary or time dependent of the model because we want to find the temperature distribution as function of time. So we click on time dependent or transient simulation. Okay, click on that. In this section, we need to define our domain of the model. So right click on geometry, click on rectangle. We have two widths and also two height. The dimension are meters. Click on build. Okay, now we click a circle. Okay, its radius is 0.5 meters. Click on build select and base center. The x value is 1 and y is also 1 meters. Build select. Now we have circle on the center of the rectangle. Okay, now we move on to materials. Right click and click on add material from library. We go to AC and DC. So we select copper and aluminum and add to component. Okay. The copper only the center domain or the circle. So we clear the rectangle. Okay. So now let's move on to aluminum and select this domain because this domain is aluminum. Okay. This aluminum and this copper. Okay. Now let's move on to heat transfer in solid. Okay. The initial temperature for our domain is 290. Okay, the unit is Kelvin. So we need to define heat source. Select the copper domain. The heat source value is equals 1E6. Okay. Now let's move on to mesh. Use fine mesh. Okay. Build all. Now let's move on to step 1 time dependent. Here the start time is 0. The time is step 0.5 and the stop is 1000. Okay. Now compute the model. Here we have temperature distribution inside the copper and aluminum over the time. The time for this temperature distribution is 1000. So here we can change the time. For example, the 0. Here you see that the temperature is 290. And also we can change time here. For example, 553. We have temperature distribution inside the domain. Okay. Also, we want to see the animation of the model. Click on animation and player. So here you see that we have temperature distribution as function of time. Here we can increase the number of frames. For example, if we use 100, so the temperature distribution now we can see that. Run again. Okay. Also, we want to show or we want to find the contour of the domain. Right click on result, click on 2D, and right click on 2D plot, and we select contour. Okay, now plot the contour. Here you see that the contour of our model. Also, we can show the animation of the contour. So Again, click on animation and click on player. So here you see that the contour of our models. If you want, export the model as a GIF or the movie. So here we change the target to the file, and here you can change the format or GIF or AVI. So for example, I want a GIF. Here you need to define the file name or the location. And another option here you have, for example, the number of frames. For example, I use 50. Now click on export. Okay, now back to COMSOL file. Also, we want to calculate or plot the temperature inside the domain or the center of our model. We want to find the temperature as function of time. So we go to datasets and cut point 2D, use 1 and 1 for x and y. So here plot. So we have a point in the center of the circle. Okay. Now back to result. Right click on result, 1D plot group, and also point graph. Okay. Now here we select the path point 2D, that is point of center. So we want to calculate temperature as function of time. So click on plot copper domain. The temperature increases as function of time because we have heat source inside the copper domain. Okay, thank you for watching the video and good luck.